When we convert from scientific notation back into our ordinary or standard notation, we kind of apply the rules backwards. So here we have 2.9 times 10 to the 3. What that is going to tell us is that we need to move the decimal 3 times to the right. So what I usually do here is I go ahead and write my original number, and then I add the same number of zeros that the exponent has. Sometimes I don't need them all, but it gives me enough to work with. Then what I do is I take my decimal and then I do the little bumps, 1, 2, 3, and that lets me know where the decimal is supposed to end up. You can see here that I did not need that last 0, so I'm not going to include it, and my answer is just 2,900. For part B, we have 7.36, and this time it's to the negative 2. So again, we're doing backwards, and so I'm going to go ahead and put 2 zeros in front. And now for that negative 2, that tells me I'm going to go 2 decimal places to the left. So my answer is 0.0736. Now you don't have to do the bumps like I do, but I find that this is an easy way to keep up with what's happening. So the procedure written out in steps. The first thing, if there's no decimal written, go ahead and write a decimal after the last digit. Now usually there will be a decimal there, but just in case, you can just write a decimal after, after the digit. And then the power of 10, that k, is going to tell us how that decimal is moving. If k is positive, then we're going to be moving the decimal place to the right this time. Again, remember, this is going to be backwards. If k is negative, then we're going to be moving that decimal point to the left.